Hello my scholars, you're welcome to my school YouTube channel. My name is Emmanuel and in today's video we'll be treating acid, bases and salt in chemistry part 4. Please don't go anywhere, stick around and we'll be right back. You are welcome back to my school YouTube channel. In today's video, we'll be looking at acid, bases, and salt part 4. Now, let's get down to it. We'll be talking about buffer solution first before talking about salt because we have already talked about acid, we've talked about bases in our previous video lessons in chemistry. Now, what are buffer solutions? A buffer solution is a type of solution which resists changes in pH on dilution or addition of small amounts of acids or alkalis. So whether you add small quantity of acids to those solutions, they don't change in their pH value. So addition, or whether you dilute it by adding acid or adding alkali, the buffer solution remains unchanged in pH. Buffer solutions include a weak acid and its conjugate base, or a weak base and its conjugate acid. Let's look at examples of buffer solutions. Acetic acid and sodium acetate. That is an example of a buffer solution. Of course, you agree with me that acetic acid, that's what we call the ethanoic acid. Okay, the trivial name is acetic acid. It's also known as ethanoic acid, and that is CH3COOH. Okay, that is what acetic acid is. And the sodium acetate. Sodium acetate is its salt. Okay, of course, if you react CH3COOH with sodium, which is a metal, or sodium hydroxide, which is caustic soda, that sodium will displace this hydrogen and it comes in here to form sodium acetate. Okay, sodium acetate, and then you have what? H2O that is formed. So the sodium acetate is actually the salt that is gotten from what? Acetic acid. So acetic acid and sodium acetate is one of the examples of buffer solution. Then we talk about formic acid and sodium formate. Formic acid is also what we call methanoic acid. You can see that we have HCOOH. The trivial name is formic acid. The IUPAC name is methanoic acid. HCOOH. Okay, that is a very weak acid and its conjugate base is HCO. So what we have is the metal coming from the caustic or from caustic soda or from alkali, okay, displaces the hydrogen that is here. They will form sodium, okay, formate, what we call sodium methanoate. So that is its acid. So formic acid and sodium formate is another example of buffer solution. Then we have hydrogen cyanide and sodium cyanide. Hydrogen cyanide and its salt, which is sodium cyanide. Then we have carbonic acid and sodium carbonate. That is another example of buffer solution. Let's move on to the next slide now. Now we want to talk about salts. We are done with acids, bases, and now salt, which is the last part of this topic. Now, definition of salts. A salt is the compound formed when all or part of ionizable hydrogen of an acid is replaced by metallic or ammonium ions. Remember that acids are said to be compounds or substances that has in them hydrogen ion concentration when they are dissociated or when they are dissolved in water. What we have is hydrogen ion is the only positive ion they are going to produce. Okay, now the hydrogen ion that is present in that acid is now being replaced by a metallic ion or ammonium ion. What we have becomes salt. So to a layman, we say salts can be what we use in cooking, maybe in the kitchen or whatever, we use in making our food, to be tasty. Okay, but to a scientist or to a chemist, salt is much more than that. So salt is any substance or compound that is formed when the hydrogen ion that is present in the acid, okay, is replaced by a metallic ion. You could have potassium ion, you could have sodium ion, you could have lithium ion, you could have magnesium ion, you could have calcium ion, you could any of those metals, okay, metallic ion, if it comes in to replace either part of the hydrogen ion or all the hydrogen ion that are present in that acid, what we have is the salt. So I want to reiterate it again that a salt is the compound that is formed when all or part of the ionizable hydrogen of an acid is replaced by metallic or ammonium ion. So which means that the hydrogen that is not ionizable cannot be replaced. Okay, for instance, CH3COOH, okay, which is a weak acid. All the hydrogens there cannot be ionized, cannot be replaced, okay, cannot be dissociated. So it's only the last hydrogen, CH3COOH, the last hydrogen there is what is ionizable. So what can be replaced there is only the hydrogen. So when a sodium is coming in, the hydrogen can be replaced. So we have CH3COONA. So that compound itself is called a salt because a metallic ion has come to replace the ion that is present in it. Also, a salt can be said to be a compound consisting of positive metallic ion and a negative ion that is derived from an acid. Positive consists of a positive metallic ion and a negative ion that is derived from an acid. For instance, NaCl, that is a common salt. So Na is positively charged ion, Cl is negatively charged ion. So these together make up the salt, okay, because we have positively charged ion and negatively charged ion. We have here sodium here and sulfate. Of course, this is a metallic ion that is positively charged, and then we have the sulfate, which is a radical SO4 2-, okay, combined together to form salt. Then we have zinc chloride. Zinc is positively charged, we have 2+, and then chloride ion is negatively charged. So that confirms the definition for salt that we said. It could be a compound that consists of positive metallic ion, which is zinc, and negative charge, and we have so many of them in that. These are just examples out of the many that we have. So if you give this as the definition of the salt, that salts are compounds that are formed when all the hydrogen ion concentration in the acid or part of the hydrogen ion concentration in the acid is replaced by metallic ion or ammonium ion, we say we have a salt. Or salt could also be compound that consists of positive metallic ion and a negative ion that are derived from an acid. So most salts are products of neutralization reaction because you can have an acid reacting with bases. Of course, remember in the other part of the video we said that when acid reacts with bases, we always have salts and water that are formed. So the salts are the products, the major products in the neutralization reaction. Let's move on to the next slide now. The types of salts that we have 5 major types of salts, okay? We have the normal salt, we have the acid salt, we have the basic salt, we have the double salt, and then we have the complex salts. Let's look at them one after the other. The next slide now. The normal salt is formed when all the replaceable hydrogen ions in an acid have been completely replaced by metallic ions of a base. All the hydrogen ion that can be replaced, that can be ionized in the formula of that hydrogen, as we saw in the previous video, that it is not all the hydrogen that are present that can be replaced or that are ionizable, okay? Those ones that are ionizable are the ones that the metallic ion is going into what? To replace. So if all the hydrogen that are present in that acid are removed and replaced by metallic ion or ammonium ion, what we have will be normal salt. So a normal salt contains no replaceable hydrogen ion because all the hydrogen ion that are there has been replaced by metallic ion or by ammonium ion. Aqueous solution of normal salt is neutral to litmus and it has a pH of 7, of course, because it is neither acidic nor basic, it is neutral. So when you react it with normal aqueous form of that salt, if you react it with a litmus paper, whether it is red litmus or blue litmus paper, it remains normal, it remains neutral to it, okay? It does not change, that's what we mean. The color remains the same and the pH of that is also going to be 7, okay? Example, sodium chloride, we have calcium chloride, we have magnesium sulfate, we have sodium sulfate, and so on and so forth. These are examples of normal salt. If you look at them, we don't have any hydrogen ion present in the formula, okay? You see NaCl, CaCl, these are the metals that are replacing them: sodium, calcium, magnesium, sodium. Here you can see that there's no hydrogen here. So that makes it to be a normal salt. And remember, we have the positive metallic ion and the negative metallic ion, positive ion, and so on and so forth. That simply is what normal salt. So in an objective question, you could be asked which of these is a normal salt. You could have MgHSO4, CaHCl, okay, maybe Cl2. You could have NaHSO4, then you could have Na2SO4, okay. The one that does not have the hydrogen ion is the normal salt. So it's very easy to identify. Once you see the salt giving out like this, you don't have hydrogen in it, you know it is a normal salt. Let's move on to the next slide now. The second type of salt is the acid salts, okay. Of course, as the name implies, acid, so it must definitely have hydrogen ion present in the formula, okay. We have an acid salt is formed when the replaceable hydrogen ions in the acid are partially replaced, not all, by what? By metal. Remember, in normal salts, we said all the replaceable hydrogen ions have been replaced, okay. But in the case of acidic salt, we still have some hydrogen, 1 or 2 hydrogen ion we still have present in it. So not all of them, they are partially what? Filled by metal. And acid salt contains replaceable hydrogen ion. For instance, we have NaHCO3. You can see that that's hydrogen ion there, okay, present in it. We have sodium hydrogen sulfate. We have calcium hydrogen carbonate. These are examples of what? Of acid salt. You can see the hydrogen there. You can see the hydrogen here. You can see the hydrogen here. So these are some of the examples of acid salts. Part of the hydrogen ion present in the acids are what are replaced. Not all of them. If all the hydrogens are replaced, what we have will be normal salt. But if we have part, we still have 1 or 2 can have hydrogen that we can still find in it. It means that it is an acid salt. Let's move on to the next slide now. Acid salts result when there is an insufficient supply of metallic ions to replace all the replaceable hydrogen ions in the acids. I'll say that again. Acid salts results when there is an insufficient supply of metallic ion. If we don't have the number of ions, the metallic ion that is coming in to replace the hydrogen, if they are not sufficient, okay, so some of them will be replaced, I will still have some of the hydrogen that will be left. So when there is insufficient supply of metallic ions to replace all the replaceable hydrogen ions in the acid, what we have will be an acidic salt. Look at example now. H2SO4 is an acid reacting with potassium hydroxide, okay, to form potassium. You can see that this is potassium, and then the sulfate is reacting with it. So we have hydrogen left. Now, this potassium now is not sufficient to replace this, because for this sulfate is actually 2 minus. That is a radical. So it has a valency of 2 minus. So which means the number of hydrogen or whatever metallic or cation that will be coming in to bond with this sulfate must be 2, because it has SO4 2 minus. So it needs 2 atoms of whatever. That's why we have hydrogen here, 2 of them that are combining this. Now, a metallic ion is coming in now to replace this hydrogen. But because this this metallic ion, which is potassium, is not sufficient, we don't have 2 of that. So only 1 comes in, and it will be able to replace one of the hydrogen ion here. So if it replaces one of the hydrogen ion, we now have K here, then 1 hydrogen still remains, and then so forth. The reason being that potassium is +1, hydrogen is +1. +1 + 1 gives us +2. So +2 here, and then this one is already SO4 is what? 2 minus. This is +1 here, this is +1 here, and then this is 2 minus, -2. +1 + 1, that's +2. +2 minus 2, you can see that's 0, so it is balanced. So, but if we had this, you can now see that if we have hydrogen here, this potassium coming in to replace this hydrogen, if it's just only 1 of that, then we know that this potassium is not sufficient to be able to bond with this guy, because this guy here has 2 valence here, 2 minus, combining power of that is 2. So it needs 2 atoms, okay, that is coming in. So since 2 hydrogen is to be replaced here, but this potassium is not sufficient enough to replace all of this hydrogen. So only 1 is replaced, and then that's why we have 1 hydrogen that is left here, and then we form water. In the presence of excess metallic ions, the remaining replaceable hydrogen ions in the acid becomes replaced, becoming a normal salt. So as the reaction Continue. If we have excess of that potassium hydroxide still reacting again with this, just like we have in this case, we have it excess potassium hydroxide still replacing with this, then this potassium now is sufficient now to now knock off or to replace this hydrogen ion, so that it becomes K now becomes 2. So we can now have K2SO4 because potassium hydroxide is in excess. So the first reaction, KHSO4, is formed because we still have excess of that metallic ion in this. Then you can now replace this hydrogen and then we form K2SO4. Of course, there's no hydrogen here, so this gives us a normal salt. This gives us a normal salt plus H2O. Let's move on to the next slide now. Basic salts. This is the third type of salts that we have. A basic salt is formed when a base reacts with a limited quantity of an acid. Just as the name implies, basic salt, okay? A basic salt is formed when a base reacts with a limited quantity of an acid. So, which means that we have small quantity of acid, the proportion of the volume of acids that reacted with the base, okay, are not proportional, they are not the same, okay? So, in that much, we have excess of bases reacting with what? Limited supply of acid. So, when all the acids that are in the reaction vessels are used up, okay, reacting with the bases, we have some amount of bases left, okay? So in that case, what we are going to have, the kind of salt we are going to, of course, we are still going to form salt, but that salt will be basic in nature. It means, remember what makes it basic? We have the OH negative, OH ion is present there as the major formula. You can tell that when you look at it. So for instance, we say the ozonium ion, which is H3O positive, is insufficient for the complete neutralization of the base. A basic salt, therefore, contains replaceable hydroxyl ions, OH minus. Hydroxyl ions, OH minus. Let's move on to the next slide. These are examples of basic salt. You can see it. Calcium hydroxyl chloride. You can see that this OH present here, okay? You can see, once you see the OH present, it shows you that it is a basic salt. Remember, bases usually have hydroxyl ion as their only negative ion when dissociated in aqueous solution or in water. So CaOH, you can see that Cl, that's calcium hydroxide chloride. We have zinc hydroxide chloride, that's zinc 2 actually. Zinc hydroxide, you see the OH present there. You have magnesium hydroxide, magnesium 2 hydroxide chloride, okay? MgOH plus Cl, ZnOHCl, calcium OHCl, and so on and so forth. So these are some examples of basic salts. You can identify them easily when you see OH here, OH here, and OH here. So a basic salt turns red litmus blue, of course, because it is basic. Remember, one of the properties of bases, we say bases turns red litmus to blue coloration. So a basic salt turns red litmus blue and reacts with excess acid to form a normal salt and form a normal salt and water. Okay, so we have MgOHCl. This is a basic, you can see that, plus HCl. When they react together, they form normal salt and water. So all we are saying is that the hydrogen that is in the acid reacts with this OH, pulls it out there to form what? Water. Then we'll be having MgCl left, because this OH hydroxide ion with hydrogen ion reacts together to form water. Then we have MgCl left. Of course, this one is what? A normal salt, because there's no hydrogen present in it. There's no OH present in it. All the hydrogen that is present in this acid have been replaced by metallica, which is what? Magnesium. So this makes it normal salt. Let's move on to the next slide now. The fourth type of salt, double salt. Double salt is a salt which ionizes to yield 3 different types of ions in solutions. Of course, that's why it's double. 3 different types of ions. When they ionize in water or in aqueous solution, you will have 3 different types of ions are what you can have in the solution. Now, out of those 3 of them, 2 of them, of those ions that are formed, will be positively charged, while the third, which is the last one, will be negatively charged. So, of course, positively charged ions are what? Are metallic ions, apart from hydrogen. They are metallic ions. So, 2 of the 3 ions that you find in that solutions are positively charged, while the other is what? Negatively charged. For example, we have NH4SO4, FeSO4. NH4 is positively charged. SO4, you can see that this is negatively charged, 2 minus, and then we have FeSO4. Okay, so if we have that plus this 6H2O, this is going to give us, we have positively charged ion here, we have positively charged ion here. Of course, SO4 is still the same, just one of that. So we have FeSO4, NH4 is here. Then we have ammonium ion 2 tetraoxosulfate 6 hexahydrate. This is what we have here. That's the name for this. Ammonium ion, this is your ammonium ion 2 tetraoxosulfate 6 hexahydrate. Hexa is the 6 moles of what? Water that we have in this place. Then we also have KAlSO4. Now, one way this one could be written is, it could also be written as NH. Okay, we have Fe could be here. Okay, another way we can have this, we can have Fe here, then NH4, then SO4. Because there are 2, we can have 2 of them here this way. So we might not open in this way, so we know we have just SO4 here, we have Fe here, SO4 at this place, and then we have that at this other part. So that's why you can see this other one now, this ammonium potassium tetraoxosulfate 6 dodecahydrate. Okay, we have D, that means 2. Then we have dodecahydrate. Deca is 10, okay, and then this is 10 plus 2, that's 12. So 12 molecules of water, that's what we have here, 12 H2O. So we have potassium, which is positively charged, aluminium, which is positively charged, and then we have the sulfate ion, which is what? Negatively charged. So this is a double salt because we have 2 positively charged ions here, 2 ions, you can see metallic ion, potassium, and what? Aluminium, and then we now have 2 of the SO4, which is negatively charged here. Then we have 12 moles of what? Water here. So these are some of the examples of the double salts that we have. Now we have come to the end of the preview of this video lesson. If you want to have access to the full video, please click on the link in the description below that takes you to the My School website. There you'll be able to have access to the full video, and in the full video we'll be talking about complex salts, we'll be talking about preparation of soluble salts, we'll be talking about preparation of insoluble salts, we'll be talking about water of crystallization, we'll be talking about efflorescence, talking about hygroscopy, and then deliquescence, and so on and so forth. I believe you enjoyed this content. If yes, please don't forget to click on the like button, hit the subscribe button, and finally tap on the notification bell to keep you informed once we upload our next video.